Hello, I'm Tongkui Yu from Southwest University of China. I will talk about the endogenous formation of an interbank credit coalition. It is caused with Professor Tony He from UTS, Australia. First, the motivation. 2008 financial turmoil, which started from the subprime crisis, brings a huge shock to global economy. It is noticed that financial stability depends not only on the health of individual banks, but depends more on their connections. The bankruptcy of one institution may spread to the whole system due to the domino effect. Greenspan said that the financial system is too interconnected to fail. So there's a critical need for the understanding of the structure and the dynamics of economic networks. The network theory is solely required in the study of a financial system. There are two types of research. The first is the empirical work, which finds the properties of network structure in the real interbank market. The other type of research is theoretical work, which investigates how different network structures affect the financial system and search for the optimal structure for the financial stability. What we are concerned about is how does the interbank network come into being. There are already some researchers have studied this issue with different network formation mechanisms. Our work differs from the literature by that we propose a two-level game. At the high level, in the longer time horizon, the banks are playing a network game. They decide on whether or not to build a credit connection with each other. At the lower level, in a shorter time horizon, they are playing a resolution game. Given the interbank credit network, the banks decide on how much of his deposits to be reserved for withdrawal and how much to be loaned out to make profit. And when decide at the high level, when decide on how or whether to build a credit connection with each other, the banks will forecast and compare the expected profit in the resolution game and the network structures with and without the connection. The ideal framework is that there are many banks. At each time, two banks are selected randomly and asked, will they build a mutual credit line with each other? If both said yes, there's a connection between them. Otherwise, if any of them said no, there will be no connection between them. And this process repeats again and again until the network doesn't change anymore. This is the concept of pairwise stability. And this is a big plan, and we only make a very small step towards this big plan. And we only consider the fully connected network of homogeneous banks with the unlimited credit line. All the banks have the same size, and they are fully connected, and they provide unlimited credit line, which means that one bank can borrow as much money as needed from other banks. This means all the banks will survive together or bankrupt together. So we call it an interbank credit coalition. Let's look at the model. First, the behavior of a single bank. For a bank with no connection with the other banks, his deposit from the customer is D. Firstly, the bank will decide how much of the deposit to be reserved at X and how much of the deposit Y minus X to be loaned out. Secondly, a stochastic liquidity demand omega occurs, which means that omega proportion of the total deposit will be withdrawn by the customers. Omega follows the distribution with CDF, gamma, omega, and PDF F omega. If the omega is smaller than the reserve, the liquidity demand is smaller than the reserve, the bank will survive and make profits. Otherwise, if the liquidity demand is larger than the reserve, the bank will bankrupt and no profit. The interest rate of the deposit paid to the customer is 1, and the interest rate from the loan is 2, and no interest for the reserve. So the bank's behavior is to maximize his expected profit by choosing an optimal reserve ratio X star. The bank's instant profit is the revenue from the loan minus the cost for the deposit times the survival probability. And the bank care about not only the instant profit but also the profits in the future. So the expected profit for a bank is the net present value of all future profits. The bank's decision is the trade-off between the instant profit and the survival probability. If they keep a very high reserve, the instant profit is very low, although they can survive at with a high probability. If the reserve ratio is very small, the instant profit can be high, but they will be bankrupt with a very high probability. So there is an optimal reserve ratio X star for the highest expected profit, which is between the zero reserve. If they keep no reserve, it is destined to bankrupt. If they keep a very high reserve, they can make no profit even in the instant profit. There are many other analytical results if the liquidity demand follow certain distribution. We just skip the details and move on to the two banks situation. Suppose two banks can sign a contract that once one bank is short of liquidity, the other bank must lend as much money as needed to the illiquid bank. So they can only survive together or bankrupt together. Then we will ask, how much reserve will the two banks keep? They are playing a reserve ratio game. The strategy of the banks is their reserve ratio, and their payoff is the expected profit. A natural equilibrium can be found to predict the strategic choice of the banks. And the intuition of the natural equilibrium is that when the bank I keeps the xi star of the reserve ratio, the best choice of bank J is xg star and vice versa. So no bank has the incentive to deviate from the equilibrium. It's stable. Due to the symmetry of the two banks, they all have the same size and everything is the same. So their reserve at the natural equilibrium will be equal. This figure shows the result of the two bank situation, which provide the key point of our work. I wish I can explain this figure clearly. The horizontal axis is the reserve of each bank because they are homogeneous and at the equilibrium each keep the same reserve. So at the horizontal axis, each bank keeps the same reserve ratio X. And the vertical axis is the expected profit for each bank. The blue line is for single bank, only one bank with no connection. The black line is for the two banks with unlimited mutual credit line. We can see that the optimal choice for saving bank at this point. And for the two bank situation, the optimal choice for two banks is potentially at this point with a lower reserve ratio and higher profit for each bank. This is because they can borrow from each other and they are sharing the risk. If one bank is short of liquidity, they can borrow from the other. So each of them can keep a less reserve and loan out more money to make profit. However, this point is not stable. It can only be achieved, if the two banks can make decisions just as one bank. However, the two banks make decisions by themselves. Each of them has the incentive to further lower their reserve. By further lower their reserve, suppose the other bank keeps this level of reserve. The other bank has the incentive to further lower the reserve because by lowering the reserve ratio, they can loan more money out to make profit. And the profit is enjoyed by himself. On the other hand, lowering the reserve ratio makes the probability of bankrupt increase. But the increased risk of bankruptcy is shared by two banks. So the profit enjoyed by himself and the risk shared by two banks. So each bank has an incentive to further lower their reserve, which come to the natural equilibrium at this point. So we identified two effects of the interbank credit line. The first is the risk-sharing effect, which each bank can keep a lower reserve ratio to share the risk and make more profits. However, due to the free riding effect, each bank further lower their reserve and make the expected profit decrease. The free riding effect can be explained by a classical Chinese saying: one boy is a boy, two boys half boy, and three boys no boy. With this idea in mind, we move on to the many banks situation. There are n banks with the same size D. They are fully connected and they provide each other the unlimited credit line, which forms a credit coalition. We can find the natural equilibrium for the reserve ratio given in the coalition numerically. Let's see the results. This figure shows the relationship between the number of banks in the coalition with the reserve ratio at the equilibrium. We can see that the equilibrium reserve ratio decreases monotonously as the coalition size increases. However, the relationship of the coalition size and the profit at the equilibrium has a nonlinear relationship. As the coalition size increases, the profit at the equilibrium first increases and then decreases. So there's an optimal size for the interbank credit coalition. When the coalition size is small, they will welcome more banks join in. Once they reach the optimal size, they will refuse other banks to join in anymore. In order to understand the relationship between the coalition size and the profit at the equilibrium, we draw a figure in this figure. The horizontal axis is the reserve ratio for each bank, just as the figure previously. The vertical axis is the expected profit for each bank. We can see the blue line is for single bank, other lines for interbank credit coalition, with the size increased with the darker color. We can see that as the coalition size increases, the optimal profit for each bank increases monotonously due to the risk-sharing effect. However, as the coalition size increases, the free-riding effect becomes larger and drives the reserve ratio be even lower and the profit decreases. Due to the two effects, the profit at the national equilibrium increases first and then decreases, just as shown in the previous figure. Then we come to the conclusion. We studied the endogenous formation of interbank coalition from the incentive of individual banks' profit maximization. We propose a framework of two-level game. At a longer time horizon is the network game, in the shorter time horizon is the reserve ratio game. We identified two effects of the interbank credit connection. The first is risk sharing, which makes the banks can keep a lower reserve ratio for a higher profit. However, due to the free riding effect, each bank further lower their reserve and make the expected profit for each bank decrease. The trade-off of the two effects leads to an optimal size for the interbank credit coalition. There are many works to be done in the future. For example, the partially connected network, the banks with different size, and limited credit line, etc. That's all. Thank you.